Hi, I'm Steve Swanson, NASA astronaut. I'd like to tell you a little bit about the spacesuits. The idea of this video is to talk about what the spacesuits are, how they work. And this is made for people who don't know much about it, except family, friends who want to watch a spacewalk, and they see somebody out there doing it, and they are just want a little more information on really what's going on. So that's the idea of this. Again, there's no script here. I'm just making this stuff, or not really making it up. I'm going along without a script. And also, I'm not an expert on this. These are the disclaimers that I'm just an end user. I'm not an expert on the suits itself, but I know a little bit about it. Done a few spacewalks. So let's start off with the spacesuit itself. I got two of them right here. One a little bit more taken apart. There are a couple different parts to a spacesuit. As you can see, we have the helmet right here. We have, this is called a HUT, which is a heart, upper torso. You know, in acronyms, we love them here at NASA. We have basically the pants, lower torso assembly, LTA. And we, of course, have arms and gloves, which are all needed, of course, to make the pressure suit work. So a little bit more about the suit, how it works. It's really a simple but robust system, I think. The idea behind it is it gives you, of course, a pressurized area, 100% oxygen inside pretty much of the suit. It pressurizes to 4.3 psi. And since we're outside, it's around 35,000 feet, like pressure altitude, if you're thinking of it that way. And it also then provides cooling for you. And of course, it removes your carbon dioxide for that. And of course, there is ventilation also to keep the air flowing around to make sure you don't have pockets of carbon dioxide build up, or also to help you with the cooling, to make sure it goes all over your body. So the way as the system works is, of course, there's oxygen tanks in the back, and then there's just a regulator valve. As the pressure drops in the suit, it opens up to make a continuous suit at 4.3. And the way it normally would drop the pressure in here, as you breathe, of course, you expire CO2. CO2 then gets scrubbed out in a canister we have in the back. And that canister then absorbs the CO2, which causes then a pressure drop in the suit, and then the regulator itself puts more oxygen back in the suit. That's how we can always keep the same 4.3 differential, and also get rid of the CO2 and keep ourselves in a good config. For cooling, there is a sublimator on the back here, and so we use a little bit of our water supply that's in here. It goes onto the sublimator plates, which then sublimate into the vacuum of space, making them very, very cold. And then we have another water loop inside the suit that passes through the sublimator plates and gets very cold. And then that water can be mixed with the other water circulating through the suit to keep you cool. Now, how does that get to your body? Well, what we're doing when we're underneath our suit, and what we're wearing before we get on is called a LCVG, which is a liquid cooling garment. I don't know where the V actually comes from, but not important. So we wear this, and inside this thing, there's little tubes. And of course, the water is going to flow through those tubes. And when we hook that up, we can hook this right up to our suit here. We plug it in, and once we get in, and that way we get the coolant throughout the whole body, or over the whole body. And that keeps us cool. Now, to regulate that temperature, we have a valve here that can be set. It goes from 0 all the way to 10. And the idea with that is at 0, it doesn't mix any of the cold water in the cooling loop. So it kind of keeps it as warm as possible. You go to 10, pretty much it's mixing all the cold water into the cooling loop and getting you nice and cold. You can vary that during your spacewalk depending on if the sun's out, how hard you're working, where you're working, is it reflective sun too? So that will matter a little bit, but most of the time you don't have to move this too much. You can just regulate yourself by how much energy you put out. If you're a little cold, you put out a little more energy, work a little harder. If you're hot, you can back off a little bit, take a little easier pace, and it will help you that way. Put this back away real quick. So as for the suit, there's a few other little things we have, of course, on it. There is a little computer in here that gives us error messages that pop up. We also, of course, have radios in here that will then we can use to communicate with the ground and the other person out doing a spacewalk with us. Let's see. Besides that, on the suit, there's not much else to it in the sense of there's other, of course, switches and knobs to help turn things on. We have the ability, of course, to open up a little hole in the suit while you're outside called a purge valve in case you need to, for it's an off nominal situation. You have a way to select which radio you're using. We have a backup. You can turn on the water pump and the fan itself that way. So it's really, again, not much of a complicated suit, and really this the fan and pump and all the moving parts are contained in one big unit called a fan pump separator. And those are, we've changed them out on these suits here before, and so along that piece is working pretty much. The whole suit's going to work pretty well for you. It's a really, again, simple but robust. I mean, you can have the whole computer die, the battery die on you, and the suit, the regulator is still going to work for you. You can just open this purge valve to create flow through the of the air, and it will work fine for you. You can, you'll come on in, but you'll be safe, no problem at all. So it's a very good suit. One of the issues we do have with the suit is the mobility in the shoulders. So that's one thing. So we have a bearing basically right here for the shoulder. And the idea is, though, where that meets on your arm can be very interesting, and it varies, of course, from person to person. But it limits you to reaching up as your arm comes up as a limiting factor on that. And so we have to be very careful about how far we reach up and what we do with our arms as we're going out there and try to do different movements with your arm to keep that safe for us and not hurt our shoulders. So that's pretty much for the suit. So let's go on to how to get ready for a spacewalk. So the idea, what we have to do, of course, is you start off with getting ready, and you're going to do that by putting on long underwear. Pretty much that's all it is. It's just a set of long underwear. That's the first layer. Of course, I guess the first layer under that is a diaper, and yes, we do wear diapers. It is needed. You're in a suit for 9-10 hours easy, and you're going to need that, no problem. So we put on the long underwear. You're going to then also put on electrodes for a heart rate monitor, basically, so we'll get heart rate and that data shipped down to the ground so they can watch your heart rate. And they really use that to figure out that, along with how much oxygen is being put into the system, kind of what your metabolic rate is, how hard you're working, and how much of a stress you're putting on the suit itself too. They have to monitor all that for us to make sure everything's working properly. So once you get yourself all suited up, or at least with the long underwear on, then you go ahead and put on the LCVG. And at the same time we're doing that, we're actually in this area called the equipment lock. And the idea is we need to get the nitrogen out of our blood, just as you were if you're going scuba diving and going down deep. So to do that, we have to start breathing 100% oxygen. So we'll put on a mask, start breathing oxygen, and we'll do that for about an hour as we bring this area down to 10.2, which is around 10,000 feet pressure altitude. When we're all done with that, we'll have we'll can come off the oxygen. We'll be at 10.2 here, and then we can continue on getting into the suits. So again, from that point on, we go ahead and put on the pants or the LTA. We'll do that in here, and that's not too difficult. You need somebody to help you. They're a little tough. It is a pressure suit, so there's a big bladder in here, and so you can see this. This is just a really thick plastic bladder, and it makes it a little more difficult to get into. And then just as another idea, the suit, the outside here is a protection for thermal and for micrometeors. So you put that on. Once you get that on, you're going to go ahead and slide yourself, take off the helmet here, and then you're going to slide yourself in up through this way, getting your arms into each side over here, and then pop your head up through. And at that point, then we can go ahead and hook up the LCVG here, hook up your heart rate monitor, do that, and you can button up the LTA at that point, and then we're again, and you're halfway there, ready to go at this point. And then we'll do that again for both suits. So once that gets that far, we'll do that for the other person. And then when you're definitely ready, you've had your last little bit of food if you want it now or anything like that, we're going to go ahead and put the helmet on. And then that's all closed up. We also need to put on the gloves. It's the same type of process with the glove. We wear a little bit of a glove underneath it, just a little cotton glove underneath it to help protect our hands a little bit. And then put this on. And then this is a pressure suit. And they've done a really good job on these gloves, making this area here very robust. It's an RTV type of material, but also very sticky at the same time to help you with dexterity. So the gloves go on too, helmet comes on, and at that point you can go ahead and we'll get rid of the oxygen, or the nitrogen by doing a purge, which is 100% oxygen, to try to get rid of all the nitrogen. And then we start some more pre-breathe at this time. And it's about 3 hours from this point on, pre-breathe, and we have to do light movement at the same time to kind of help get the nitrogen out of our system by making our metabolic rate go up a little bit. So we work on that at this time, getting the nitrogen out. At that same time we're doing that, we're going to open up this hatch, come back up to normal pressure in this area. So the guy who's helping us set up can move around some more. Once he's done with all of that and have us all buttoned up, the idea then, and we waited the proper amount of time for our pre-breathe so that we don't have to worry about the nitrogen or the bends anymore in our system, we can go ahead and put us in this area over here, which is called the crew lock, and that's actually what's going to depress down the vacuum. And it's tough to see because we have a lot of stuff in there right now. But on the bottom part down there is a hatch that opens out to space. And so what he'll do is the person who's suiting us up will put us in here, close the hatch from up here, right down, close it off from here. At that point we start the depress process. That takes about 30, 40 minutes to do the depress down to zero. Time we do leak checks on the suit at that time, make sure everything's good to go, everybody's all happy, they check all the instrumentation, make sure it's all good to go, and then we're going to go out and do a spacewalk. A little bit about the equipment we use during a spacewalk. You know, how do you keep yourself safe? That's always the biggest thing we worry about. And one of the big ways we do that is with this safety tether. So the idea right here, the safety tether, is when we get out, first thing we're going to do is we're going to attach this to structure somewhere outside, somewhere on the outside of the station. And it hooks on and actually then has a locking capability. So then this can't pop off by itself. It takes two actions. You have to unlock it and then move it to get that thing to come open. And what it has is a cable. It's a wire cable. This one's a 55-footer. We have also an 85-foot cable. And we use these where we go. Well, sometimes, since the station's now gotten so big, we have to have multiple of these as we go along, and we kind of like daisy chain them out to get ourselves all the way out there. So this is one of our most important things we have when we're out there. Well, you also have, so when you're working too, to keep yourself in the same area, or not moving around, as you know, right here everything floats, as you can see. I'm floating here, right here. But when you want to work with both your hands, the problem is then you're not very stable, because if you pull and push on something, you're actually pulling and pushing on your own body too. So in the inside station, what we'll do in that way is I'll lock my feet like into a handrail, and that way I'm stable and I can then work with my hands easily. The problem outside is we don't have that ability with the system to really lock our feet in. There is a way to do that on the outside of the station. We call it APFR, which is a foot restraint. However, there's a lot of overhead involved with those. They can only go in certain places on station, so we only use them when we really, really need to. So otherwise, without that, we have to figure out a way to get ourselves stable while we're outside. And we have a couple different ways of doing that. You have a local tether, which is it comes off your waist. It's about this long. And it keeps you safe in that area, so in case you do come off, you let go of structure, you're not going to go far. What we also have is, move this out of the way a little bit. On your mini workstation, that's what this is called right here, we have this piece of equipment, which is called the end effector on the mini workstation, or more commonly known as a grabber daddy. And the idea is, so if I want to go ahead and work on something nearby, I can go ahead and put this on, clamp it onto something, and then I can lock it, and then it'll stay right there for me. And that way I'm a certain distance away from a bit of structure, and I can work this way, and I'm not going to come off. And now I can still rotate around a little bit, and so that I still might want to, in certain cases I might want to be more stable. So what I'll do there is I'll use this, which is called a BRT, or body restraint tether. And the idea with this, I can then move this around. It's got a ball stack joint in here, which means I can tension this up and make it really stiff. And that way it won't move. So I rotate this, and now this thing is very, very stiff, and I can be however I want to. I can put it in a position, and now I'm not going to move much around that spot. And then when I'm done, I just loosen it back up, and it bends, and I put it back away, out of the way, and it's good to go. Now we also use this to carry things with us. So say we had something that we wanted to carry with us, and I'm trying to look where I put that. I have a bag somewhere. What we can do is this opens up again, and it goes on a handrail, clips in, and then we carry that around with us, whatever it is we're carrying. The next thing we always have to worry about is losing stuff, and so for that reason we have what we call arrettes, or retractable tethers. And the idea with these things is every piece of equipment we have, whatever we use, a bag, a tool, whatever it is, we have one of these on them. And the idea is I can connect this, like I say here, on my main workstation, and then the tool, which this is called a pistol grip tool, or basically otherwise known as like basically a drill. It's actually a power tool. All it really is. So now I can use this wherever I want to, and it just sucks. If I let go of it, it sucks back in, and I'm not going to lose it. And the more you think about that too, everything becomes very interesting. Like we have these sockets, of course, on the end of these tools, and sometimes you have to change out a socket. So then you got to think, well, how do you change out a socket and to keep a tether on this? There's no tether point on it. Of course, the wonderful engineers at NASA were pretty smart about this one. So we use this little pip pin, design it this way so it'll come off, and now this won't come off this way, but it can only go on and off while this is attached. It's a pretty unique design. I think it's actually pretty interesting, but now it's safe. So with everything we do, it has to be always tethered. You can never have something untethered for us going outside, because we're definitely afraid of losing something. So that's pretty much it for, again, the main stuff. So again, what we do, I'm trying to think other things to talk about. We have I think that's pretty much it for the suits. Hope it was enjoyable. Take care.